Hello, this is Scott. Welcome back to my YouTube channel. I cover a variety of different data science analytics topics, everything from open discussions to software demonstrations. Today we're going to have an open discussion on Bayes' rule. I did this a week ago, and I kind of did a whiteboard session, and I got some mixed feedback. Some people liked that session, and some people just didn't think it was clear enough. And since I had done it with a mouse, I thought I would go back and actually do it with a PowerPoint. So this is what I'm going to attempt to do is walk through Bayes' rule and without formulas, right? So I'm going to go step through an example, but we're not even going to talk about the formulas. We're just going to talk about the intuitiveness of Bayes' rule. So here we go. So let's suppose that we have a disease in a population, and that disease, it's a virus, and that virus occurs in 1% of the population. And so in that, if you do a test for this particular virus, you get a positive result and the virus is present 80% of the time, and the test is positive and the virus is not present 10% of the time, false positive here. So true positive 80%, false positive 10%. And so if we were to look at 1,000 cases, and those were to be screened, then the people with the virus, there's only 10 out of 1,000, 1% of the people will have it, 99% of the people do not have it. Therefore, if we look at the numbers, the people with the virus that test positive, there's 80% of 10, that's 8 people, right, that actually have the virus and test positive, and 9 out of 990 people with the virus, 10% are going to test positive. So that is 99 people that actually do not have the virus and test positive. So if I look at that and I compute those odds, what's in red is anybody that tests positive. That's on the denominator, right? 8 plus 99 is 107. The numerator are those people with the virus that test positive, and that is 8. So 8 out of 107, that's about 7.5% of the people that test positive actually have the virus. So this is an example of Bayes' rule, and certainly it's current in our time to look at not only people that test positive, but the incidence. And so we're in the midst of COVID-19, and I don't know anything about the accuracy of this test, so this is not saying anything about the accuracy of the test, but it's something to keep in mind. And what really drives this is less than the accuracy. Obviously, if we make the test more specific, we higher positive rates with the virus being present, we also are going to raise the rates of false positives that you're going to test positive with no virus. So those are trade-offs, and this is what we control. What we don't control is the disease in the population, be it 1% or whatever it might be. This is a number we don't control. And this is one of the, if you look at the math of this, the main contributor to what's driving this low true positive rate is that it just occurs, the disease occurs very rarely in the population. So anyway, I'll end there, and I hope you can join me next time. See you soon.